Welcome back to another video. Today we're going to be discussing two subjects plus an extra thing. So we're going to discuss the extra thing first. So today I'm going to be identifying a leaf for you, because this was picked from a tree. This leaf right here. It's, as you can tell, it's a little rugged now, but before it was longer and it was kind of pointing kind of on the sides, and it has like more of kind of like an oval shape. Rounds off towards the bottom and it's pointy on top, and that was found in the southern Illinois region. So by doing my research, I found out that this is a beech leaf tree, part of the Phagos family. The locations of this tree are North America, Europe, and Asia, and some locations in a location in North America is the Midwest, preferably southern Illinois. This is an American beech tree leaf. There's European beech tree leaves, Asian beech tree leaves, and American beech tree leaves. And this is an American beech tree leaf. Some common uses for it actually is beech wood is actually a very good wood for fires. It's a very good firewood. It burns for a long time and has a good aroma to it, and it's a very good overall firewood. Slats of beech wood are used in fermentation tanks for Budweiser beers. So the reason they do this is they use the slats of beech wood to leach out any other flavors or aromas in the fermentation tanks after they get done with the use. You'll find that beech logs are also used highly in German-made beers to dry malt for the beer. So they use the beech logs to dry the malt for the beer so they can brew the beer in German-made stuff. And beech wood is actually also used in military rifle stocks, like wood grain stocks. They're used highly in them because they're pretty sturdy. Like, that kind of goes along with firewood. Like, they burn for a long time. That means they're pretty sturdy, and they're kind of durable. So that's the same thing. Like, for military stocks, like, they work fairly well. So now we'll jump into economics. So in economics, we're going to be talking about terms of trade and gains from trade. So I know I showed you the production possibilities curve, which is, I used a ruler, so it's a way better looking graph, but that's my graph for the production possibility curves of of shirts that made and pants that are made. As you can see, with the straight line being that, because it's a straight line, that means that it's usually a a constant value, meaning like the same number. You'll get the same number of shirts and pants every time that you get made. So, say you have company A can produce a max amount of 20 pairs of pants and a max amount of 10 shirts. So, and company B can produce a max amount of 30 pants and a max amount of 45 shirts. And you want to know, if you're going to focus all your time on one thing, how much of another will you lose? Like, if company A focuses all of its time on pants, how much money will it lose in shirts? Or meaning your opportunity cost. So a way to find this is you can do so we'll just do company A. So you want to find out how many pairs of pants you get per shirt. So to figure this out, you could do 20p equals 10s, because you're just trying to figure out the equal amount. And with doing this, you would divide by 20 on both sides of your equation, so then you would get p equals 1/2. So for every one pair of pants, you get half of a shirt. So for every 2 pairs of pants, you get 1 shirt. Every 4 pairs of pants, you get 2 shirts, so on and so forth. Same thing for company B. You want to find out the amount of excuse me, hold on. you want to find out the amount of the opportunity cost of pants again. So in this case, you would do 30 divided by, or 30p equals 45s. You divide it by 30 on both sides, and then you get 40 divided by 35, which is 1.5. So in that case, you get 1.5 shirts per pair of pants. Company B does. So in that case, Company B would be better at producing, would have less of an opportunity cost because they're still getting more when they're producing the same amount, which, if you can remember right, that is the comparative advantage, or no, it's absolute advantage, because you're putting in the same amount of materials, but you're getting more of an amount than your competitor. The last thing we're going to talk about is we're going to talk about mathematics. So, I'm going to write you a problem, and I'm going to help you solve it. It's all we're doing today is we're going to be combining like terms that are fractions and decimals. So we'll give you the problem: negative 1 over 6 f minus 3.2 plus 5 over 6 f. Okay, so your equation, if you can see that, says negative 1 over 6f minus 3.2 plus 5 over 6f. And you're trying to combine your like terms to figure out, what is it? You're trying to combine your like terms and simplify your expression. So, to do this, you combine your like terms and you get negative 1 6 plus 5 6. Since they have the same denominator, obviously, you can just add across. So negative 1 plus 5 is going to be 4. So you get 4 over 6f. And then you just keep your 3.2. And then your final answer is 4 over 6f minus 3.2. And same thing with decimals. You can do, our next equation will be negative 3.8x minus 5 plus 4.8x. So in this case, you would do negative 3.8 plus 4.8, which is going to be 1. So you would get, instead of writing 1x, you could just write x. So you'd end up with x minus 5. Fairly self-explanatory, fairly easy, and fairly not a hard concept to grasp. That is going to do it, though. Thank you so much for watching, and I will catch you in like 2 days for another video. God bless. Take care. Peace out.